we're going to go ahead and get started. So I'd like to welcome our panelists and ask them to go ahead and turn on their cameras and microphones at this time. Welcome everyone, and thank you for joining us tonight. What I'd like to go ahead and start out by doing is have each of you go ahead and introduce yourselves and let us know exactly what your title is and where you work. Megan, can we go ahead and start with you?
Certainly. My name is Megan Chang, and I work as a professional engineer at Teeter Architects and Engineers. Yeah.
Fantastic. And Edgar?
Yeah, I'm Edgar Sanchez. I work at Mangini Associates, Inc. Incorporated. I'm a senior project manager here.
And Nick?
Good evening. My name is Nick Messia. I'm the Public Works Director for the City of Visalia, and I'm a professional engineer.
Thank you, and we really appreciate your time tonight. So Megan, let's go ahead and start with you. What's it like to be an engineer, and what does a typical day in the office look like?
What's it like? I'll start with a typical day in the office. First of all, my office varies depending on which project I'm working on and what part of the project I'm working on. In the early development parts of a project, if it's designing something new, I'm usually going to be in the office, heads down, doing a lot of work on the computer, working in teams, either with my project team working on the structural documents or working with architects and mechanical and electrical and plumbing engineers as we collaborate and put together drawings that can incorporate and accommodate all of the various systems so that nothing is in conflict. If it's the beginning part of working on an existing building, whether we're making it, refreshing it for some new use, or maybe it needs to be retrofitted because it's not quite as safe as the new standards are, then I'll probably be out in the field doing a lot of field work, crawling around in attic spaces, crawling in basement spaces, measuring, just kind of seeing what is out there. And the design part of the project, again, mostly at the desk, working in teams and meetings. And then when the project is in construction, I'm out on the site taking a look at what's going on and making sure that it's being built according to plan. And when questions come up from the contractor, I'm answering them. So where I'm at and what a typical day looks like is pretty different depending on what day it happens to be in my life.
There's a lot of variety.
There's a lot of variety, and that's one of the reasons why I love it. I'm sorry, what was the second part to your question?
I think you answered it. What does a typical day look like in the office, and what's it like to be an engineer? I think you kind of summed it up well.
All right.
So I'm going to pop down to you, Nick, because you're also an engineer. Can you let us know, I know you're the Public Works Director right now, but you're a forward city engineer, and a city engineer takes care of our roads, buildings, bridges, water supply, etc. What does that all mean, and what does a typical day look like?
Just as Megan spoke, the typical day has a wide variety of different opportunities. For a typical engineer, you could be in the office focusing on designing a set of plans, working with another consultant, whether it's in any of those topics that you just spoke of, or you could be actually out on the site working with contractors, building those same things in real time. I think that's the variety that really sparked my interest and why I wanted to become a civil engineer, is because of the opportunity to be both inside and outside of the office.
Sounds great. Yeah, I like variety as well, and not sitting in one place at all times, so I can appreciate that. And Edgar, how about for you? What does a typical day look like for an architect? And are there a lot of long hours involved in that?
Yes, there is, but however, I mean, our company here tries to find a good work, family life balance, so that's always good. But yeah, typical day, again, yeah, depending on what phase we are, where we, you know, we have certain names from schematic design, design development, just where we're at in the phase. The earlier, you know, it starts down from doing a hand sketch on a piece of napkin or meeting with clients and then kind of figuring out what they want to build, what their needs are, interviewing people, which is always my favorite part, that it's that personal kind of touch with the clients. kind of making their kind of vision come to life, which is one of my favorite parts in architecture. You get to kind of realize someone's vision and kind of draw it out and let it be built throughout the whole process. So again, it's following from drawing a sketch to all the way to walking it through construction, like our engineers have spoke of.
So what made you want to be an architect?
I was always good at drawing and math. So I was real little. My mom I like to draw a lot. My mom had a friend who was an architect. And, oh, you should be an architect. All right. So it just kind of stuck. I was like 11 years old and I kind of stuck with it. And I just kind of knew that that's what I wanted to do.
So I'm going to stay with you for another moment here. Nowadays, a lot of things with architecture, I understand, are done on the computer. So do you have to be a good artist or able to draw to be an architect, or is everything done on the computer now?
Yeah, when I was in college, I went to Cal Poly. There was a transition. There were still old school people that were sketching stuff, and there were people starting to model stuff on 3D and computer-aided drafting. Back then, there was a program called FormZ. So I got caught kind of best of both worlds. And back then, I mean, it's a lot easier to sketch something for people that you can feel that you feel your hand, you feel your sketch, you feel more free. Whereas being on a computer, you have to learn how to kind of see how the mouse works, there's that disconnect. However, I mean, I did know I was good at drawing. However, my drawing did improve. If you're not good at drawing, that doesn't mean you can't be an architect, because drawing, it can also be a learned experience.
Practice makes perfect.
Yeah, exactly. So like with anything, you have a passion for it, you want to learn how to do it, you're going to learn how to do it. I went to a lot of colleagues of mine, when I went to college, they didn't know how to sketch for nothing. Now they're like top designers in their firm. So there's no limit. If you want to do it, you can do it. Don't let whatever skills you have or don't have kind of set you back. So, yeah.
So we did have a question in the Q&A pop up, and they said they're asking, what kind of math did you have to take in college as part of the curriculum for architecture?
Well, okay, like I said, Cal Poly, I mean, architecture, you don't have to go as much as you do like with engineering. I think my highest math was like calculus 2 and like physics 2. So that's the kind of highest math that I recall. I mean, do I use that math now? No. Do I use trigonometry? I probably use trigonometry. But do I use the discipline that those math taught me? I sure do, because it's all learning, it's all processing, it's all relative.
So let's have Megan and Nick pop in on the math question, because obviously math is a big part of engineering. So how far do you go with the math? Did it come easy automatically? I've heard some people say they struggled with math in high school, but once they got to college, things kind of fell together for them. What are your thoughts?
Go ahead, Megan.
Tagging.
All right, I'll take this one. As far as math classes, they come in two flavors in college. The classes that you know are math classes because they're called calculus, differential equations, multivariable, and vector analysis. And you take those with a bunch of other majors. And then you get the math classes that are disguised as engineering classes, which are actually usually the much harder math classes, anywhere from statistics, specifically to engineering. And to give you an idea why that's useful, you don't really know when an earthquake is going to hit, how strong it's actually going to shake the area around you. And so you have statistics, you gather data, you formulate it, you collate it, and then you use various ways of looking at it to prepare for how you're going to design your building. As far as your aptitude for math, I would say you can't stink at it. You definitely have to be able to understand the numbers, but it doesn't have to be your favorite subject. I was always much better at literature and language than I was at math. Math was middling for me, but I could stick with it. I got myself through the classes. And when you're actually practicing engineering, the math you do as a practicing engineer isn't that hard. You're mostly following equations. If you want to be a type of engineer that's more into research and development, or more into programming different things and coming up with the code that we have, you're going to be using a lot more of the higher level math in your profession. So depending on how much you like math, how much you want to use math, there's a different portion of engineering for you, but you can't be failing math to be an engineer.
So to couple on to what Megan mentioned, yeah, we engineers typically go through your standard math classes all the way up to Calc 4 differential equations. You have 2 years of physics, a year of chemistry, biology. Those are some of the sciences, but there's some hidden math in there, statistics, thermodynamics. And then you start diving into your core classes where as you get further into your career, you start diving into structures. If you're a civil engineer, structures or soil mechanics or transportation, where you get to look at those, or hydraulics, the very specific equations and math formulas that help you analyze and solve those engineering problems. And a lot of it is based on math. And just as Edgar's mentioned, did I take Calc 4? Yes. Was I great at it? No. Do I use it now? Probably very little. If I maybe thinking about it is the most I've ever used it. But other than that, that's the limitation for the math.
So Megan, what types of engineering are there?
Oh, I don't even think I could shake a stick at most of it, but I'll start with the majors that were at UCSD, which is the college I went to. The engineering majors, you had structural engineering, which is what I do. That's related to either buildings or bridges. There's geotechnical engineering, which relates to the soil and how the dirt underneath you is going to react. There was environmental engineering. There was mechanical engineering, and that branches off into a myriad of different places all by itself, anywhere from designing automobiles to designing air conditioners. There was aerospace engineering, which is a subset of mechanical engineering. There was chemical engineering, bioengineering, material science engineering, some of those hybrid, which is kind of fun. One of my colleagues combined bioengineering with material science, and they design prosthetics. So you can also combine the different paths of engineering. And then there's computer engineering, electrical engineering. I'm sure there's even more, just keeps evolving and you just get more and more specialized.
Very good. So Nick, what kind of education do you need to be an engineer? Typically, is it a 4-year degree? Is it a master's? Are we looking at a PhD?
If you want to be registered, you need to have a 4-year degree. When you're going through your college career, usually you'll end up taking the engineering and training, or the FE, which allows you to then practice underneath an actual professional engineer for two years here in California. And then you're allowed to, once completing college and completing those 2 years, you're allowed to take the professional engineering exam and then hone in on one of those fields that Megan actually identified.
So I have a good question from the audience right now, and I like this one because we've got engineer and architect here. How do engineers and architects work together on projects, and who's responsible for what part?
I'll start off with this one. There's a long-standing joke that engineers, all of our best work is always covered up by the architects. What you usually see coming up first out of the ground, you see the beams, you see the columns. If you get to walk around, you'll see the concrete foundations. That's mostly what the structure of a building is. The architecture, I'll let Edgar go ahead and speak more towards that. That way I don't throw my bias on it.
No, yeah, I agree with Megan. And actually, Megan, I like to expose a lot of my structure. Thank you. Some of my buildings. No, but yeah, it's yeah, the way we work together, again, I mean, at least the way we do, we're the architect, kind of head of the design, and then we work with a myriad of engineers. We got a structural engineer, mechanical, electrical, civil, and we kind of all work together to put the project together, and they all have their part. And depending on what they're doing, we kind of meet together, we coordinate, kind of walk it through. And we're working as a team. If you learn any skill right now, learn how to work as a team. In high school right now, I bet your teachers probably put you together. Maybe not right now, but you work in groups, and you got to learn how to do that. You got to learn how to work with people and kind of share ideas and not kind of just hone in on what you're doing, and kind of just, yeah, learn how to learn. Kind of what I would recommend.
I think that group work idea has come up over and over in each of our Ignite Your Curiosities. And I don't think students sometimes realize the importance of being able to work with others and communicate with others. Falls into every profession that we have. I do have another question in the Q&A. It says, what's the most used software for modeling and designing in your industry? Anyone want to take that one?
I guess I could start. I mean, modeling itself, again, it depends on what firm you're working for, what kind of projects you do. We start off with some like simple stuff. What do we call it? It's Google SketchUp. We start with that to kind of just get some masses to put together. Had to kind of walk some ideas through and kind of start quickly. We used Revit now is a program that's being used. Again, I don't use a lot of these. A lot of these are like my colleagues use, and I got to manage them. But yeah, they're really good with it. They can start doing some massing with that. So Revit and Google SketchUp, some of the stuff we use.
How about with the engineering? What programs do you typically use?
For engineering, there's usually two different types of software. There's a software that creates the drawings, and for that we use a lot of the same programs as the architects. We use Revit a lot, which is a three-dimensional representation of the building and the systems. And we also use, to a lesser extent now, CAD. It used to be you went from hand drafting to CAD, and now almost all of our drawings are in Revit and three-dimensional. And then on the calculation side of things, I'd say the most commonly used programs would be programs where you actually build a three-dimensional model of just the structure. There's a couple big players in there. RISA is one of them, and RAM is the other. And then always Excel to help you with all of your repetitive hand calculations.
Very good. So Nick, what's the best career decision you ever made? Because it sounds like in talking to you, you've made different career moves from place to place. Tell us about that.
Well, first of all, I love the fact on what the district has done with CTE and provided this opportunity for kids in high school, because if I had this opportunity, I probably would have made a lot more earlier decisions before ending up making those decisions well into college and paying money to make those decisions. So when I went to college, I didn't know what type of engineering I wanted to be, mechanical, civil, electrical. I had no clue. And I actually paid money to take a course and figure out what I wanted to do. And slowly I evolved into civil because of the different opportunities. But what type of civil? Because civil has a wide variety, as Megan mentioned. Civil can be soils, can be structures, it can be transportation. And eventually I ended up landing on transportation because it affected a lot of different people. So through my career, I started out in doing a lot of transportation related projects, roadways and traffic control and traffic signals and light rail, things like that. And then slowly, as I moved my career from the private sector as a consultant into the public sector, I ended up changing and going back to my roots and overseeing a lot of civil construction, such as culverts, buildings, roadways, and again, back into the transportation. And now I oversee a lot of engineers doing a lot of different tasks. So my career has gone from one extreme back to the other in a matter of 20, 25 years.
So I know there's a lot of tests or certificates that you have to get to be licensed in each of your areas. Also, the schools that you go to, especially with architecture, there's certain accreditations that they have to have. So Edgar, let's start with you. In terms of picking a school for architecture, what do students have to look out for? Because I know Fresno State has just started a program. We've got Cal Poly. There's a school down in San Diego that a lot of students from COS transfer to. What do students need to be aware of?
Yeah, so yeah, back in my day, again, when I was first in high school, it was very important that that college was accredited, like you said. Not too many were. I want to say, well, Cal Poly was. I want to say Cal Poly Pomona and a couple of other private schools. I want to say UCLA had an accredited program. But again, when I applied, I made sure it's an accredited program. Um, did I answer the whole question?
What's the accreditation because that what they're looking for? I mean, I know we have WASC accreditation for high schools, elementary, middle schools, and colleges, but is there a specific accreditation that they're looking for?
I couldn't tell you specifically at the
Fair enough.
university level. I know there is. I know there's a list of them, and I know there's a ranking for them as well. So I mean, couldn't tell you what agency it would be, if that's what you're asking.
Fair enough. And how about for engineering?
For engineering, you also want to look for an accredited university. The main accreditation agency is ABET, A-B-E-T. And one of the main reasons why you want to go to an accredited university is because if you do that, then some of your schooling counts towards the work experience requirement that you need to take your exams. If you don't go to an accredited university, then you don't get to count those 2 to 4 years in college towards your work experience, and you have to work that much longer before you can even take your licensure exams. And then as Nick already talked about, there's 2 parts, 3 if you want to be structural engineer in the licensure process to become structural. Most engineering, you just have a 2-step process, which is your FE exam and then your licensure exam.
Very good. Edgar, do you have to take any kind of exams once you finish your architecture program or do internships?
Oh yeah, yeah. Like Nick just said earlier, very similar. You finish school, you get 4 to 5 years, counted towards your 7-year total that you need. So again, you before you can start taking exams. So say I went to Cal Poly, they gave me, I want to say, 4 years credit, even though it was a 5-year program. So that then I had to make up the other 2 years, with just working under an architect and kind of keeping track of all of that. And then I was able to start taking exams. And my exams, it was a total of 7. Back in my day, it was, yeah, there was a total like maybe 6 multiple choice exams I had to take, different phasing, different types of exams. We went from structural to electrical to mechanical, through construction administration, and kind of the whole myriad of what you're supposed to know a little bit of or a lot of. And then we would have, California has a supplemental exam, which if you don't pass that exam, you can't really call yourself an architect. That's your license. Once you're licensed, you can call yourself an architect. California has that special exam, again, because we live in a high seismic zone, earthquakes and a lot of safety things like that. We have to, and then just overall California code regulations, we have a lot of specialty kind of things that we need to know by code, and that's why we have that supplemental exam.
So one of our Q&A questions is, how often do you have to renew your license or the exams, or how does that process work for all of you?
So for the civil engineer, you have every 2 years you renew your license once you're a professional engineer, and you don't have to take an exam currently to renew or show continuing education. However, I'm also a professional traffic operations engineer, which is a different certifications to operate traffic signals, and that requires ongoing education over the course of 3 to 5 years. I have to submit every time I want to renew my PTOE.
Very good. Okay, so we've got a couple more questions from the Q&A, and then I'm going to go back to the questions that we have in front of us. Average yearly salary in your areas, what are we looking at? So if you've been an engineer or an architect, say 5 years, what income would we expect typically in this area?
Question for me?
All of you.
I can start. For an architect, you said 5 years in, maybe. You're looking at a range from, depending on the company, you know, what type of work you do, between 80 and maybe 110 to 120 a year.
And how about for engineering?
I'm not entirely sure. Nick might have a better idea for this area. I actually started working in San Diego, but I think our EITs, let's see here, I'll do some quick math, probably start in the 40-ish to 50-ish $1,000 range.
Very good. And private versus public?
Yeah, that's kind of a big difference. This is the more private side. I'm not sure what the public side has, Nick.
Yeah, when I started, was it roughly 20 years ago, I was making 40 to 45 right out of college. That's with a master's degree also. However, yeah, that was in the private sector. So the public sector is a little lower. What you gain between the two, if you work in the private sector, you have usually a little bit more higher end projects. You have an opportunity to take on a little more responsibility. With the public sector, you focus on certain projects and you got stability in the event that there's a downturn in the market. So there's a little bit of a catch between the two on where you want to work. But as you get 5 years into it, you're in the 60 to 70. It's equivalent to an architect.
Very good. So Edgar, we've got a question. I know you covered a little of this before, but can you kind of review what a day for an architect looks like? Are you at the desk all day? Are you out at the site? What are you doing?
Okay, yeah, again, depending on where we are with the project. Like right now, we have some stuff in construction. I'm a project manager that manages other architects. So I kind of check in with them, kind of see where they are with their projects. And then I have my own projects. So right now I have some projects I have to go look at like on a weekly basis. And I have the projects I'm still in design in that I kind of make sure all my drafting staff is busy and they have enough work to kind of put drawings together. So a day in my life might be sketching to drafters coming in and asking me questions and how do we do this, how do we do that, and how to basically solving problems and coming up with solutions and kind of moving projects through the phases.
Okay. Also, I mean, if you get a degree in architecture, do all architects just design buildings, or what are other career outlets for an architecture degree?
Wow. Yeah, I mean, if you think about architecture, it's design, and design's real general. I have colleagues of mine that went into design and started working for Disney Anime, and they're designing roller coasters and and they work for Pixar and they're designing, they're animating stuff. They're good with their architectural history, so some of their animations are real period correct. So it's, again, design. It's real broad. It's you don't have to design buildings. You just have to have that kind of angst for design and kind of solving problems and having vision and learning how to kind of make them reality.
Very good. Megan, so what's it like to be a woman engineer? It used to be kind of considered a field that a lot of men went into, but those barriers have been broken down. When you were in school, were there a lot of other women in the program with you? And what have you found in your professional life?
I guess I'll start back with college. The percentage of women in the different engineering fields varied. I'd say the bioengineering and the chemical engineering, they were almost close to 50-50. A lot of them are going into pre-med. You get to structural engineering, it was about 20% female, and this was back in the early 2000s. You get to mechanical and aerospace, you're down closer to 10%. You went into computer or electrical engineering and you were closer to 5%.
Wow.
I'm not sure what the current stats are on that. I know that I don't run into many female engineers as I go about my work. For me, that is personally a perk. Nothing against that, but I find that there's a lot less drama when you're working with men. And as far as how it's affected me personally, I mean, it has its pros and its cons. Sometimes people are going to question you, and you just need to learn to stand firm for your design and what you've been doing. And other times you get some nicer perks. I've talked to some of my male colleagues, and never once on a site visit have they been offered a bottle of water by the contractor. So, I mean, it goes both ways. But I would say overall, probably the biggest difference I've noticed is, as a female engineer, I always keep a spare pair of clothes in the trunk of my car, because if you're wearing stilettos and a skirt in the office and you get a call and you have to be out on the site, you're going to go. And you have to make sure you have on the proper PPE when you're on the site. So making sure you have your jeans and your steel-toed boots in the trunk, along with everybody else's PPE, which is the hard hat and the vest, is a lesson you learn quickly.
That makes sense. Probably one time and never did it again.
Correct.
All right, Nick, what do you love most about your job?
I'll go back to the variety. Looking at some of the Q&A, what type of projects have we done here in Tulare County, specifically the city of Visalia? It ranges from building a VEC, Visalia Emergency Communication Center, which is the dispatch center for police, emergency operations center, and a traffic management center all in one, all the way down to a trail. We've looked at different parks and recreation facilities, phase 5 of the sports park. We've done roadway interchanges. That's all within the last 8 years. And there's at least 5 or 6 that are on the verge right now, where I'm building one of my first roundabouts at Tulare and Santa Fe. Traffic signals, widening, pavement preservation. We just finished widening or increasing our capacity at the water treatment facility plant. So there's another whole different venture of civil engineering within the solid waste and not solid waste, but the wastewater treatment. So the variety, it's just, you never know what's going to be in front of you for the day. And that's what I like the most about my job in civil engineering.
Perfect. Edgar, what can students do right now to get ready to be an architect?
Yes, meet with your counselors. Tell them you want to be an architect. See what programs are out there. I know Redwood has, the engineering pathway. You don't have to do that. Back when I started, I was Mount Whitney grad. I asked my my counselor the same thing. You got to know what math you need to take. You got to know what, English, what college you want to go to, because they each have different levels. Mine was the CSU. You needed trig and calculus to get into CSU, Cal Poly. And you just need to know these things so you kind of map your plan out. Point of attack to kind of get you through it. Again, Mount Whitney had mechanical drafting, so I was back then. That's kind of like drawing by hand. We're still doing that. Right when I think graduated in '96, we were transitioning into CAD, but still, you gotta, I got the feel for, drawing, and I knew I liked the design. You get to learn about, the lab, the whole lab culture, and how to kind of work with teams and work with people around you. So yeah, talk to your counselors and see what your high schools have available.
So Edgar, did you have Dr. Odo as your architecture teacher?
He did, and I did. Yeah, he was one of my main inspirations for, he's the one who kind of carried me through, kind of recommended I become an architect, and kind of inspired me. So yeah, Mr. Odo I gave him some headaches. I gave him a lot of headaches. I wasn't an easy kid to teach, but I was real passionate. I loved what I did, and yeah, he was real inspiration to me. If you were to ask me who's your biggest inspiration, to be Mr. Odo.
Very good, very good. I love putting kids in this class. I was a counselor there. Megan, what advice would you give to anyone that wants to be an engineer?
I would say, at its basic, engineering is all about problem solving. And so as much as you can learn and as many real world experiences you can get related to problem solving, go for it. You're going to need all of your upper level classes, both in sciences and math, as well as in the literature, English, etc., if only to get your general education requirements out of the way sooner when you get in college, because your engineering class load is going to be heavy enough as it is. But if you have different, I'm trying to think of what was available when I was in high school, robotics competitions, or clubs that would be about solving a problem. I'd say show up to those, be a part of those. Volunteer with Habitat for Humanity, get some real world experience in actually building something, and seeing how things actually fit together. See if you can get on a construction site. Always make sure that you talk to the person in charge of the site and be on the site safely, but being able to go around, look at things, see how things are actually being built and how things are coming together, is all part of building a great foundation to help you continue to solve problems.
Perfect. I think I'm kind of at the end of the questions I had for you this evening. I'd like to open it up to our audience. So let's go ahead and look at our Q&A right now. So we have one young lady, we have one student saying, are there any businesses around here that are offering internships for high school students? And I'm going to start this out before I give it over to all of you. If you are in the Link Learning Academies at our high schools, we have the Architecture and Engineering Academy over at Redwood. We have several other, we have 2 academies at each of the high schools. The internship automatically goes along with that academy, and we have great partnerships with so many places here in Visalia, including the firms that each of our presenters are with today. Outside of being an academy, how would a student go about finding an internship? I'm going to open that up to our presenters.
One thing that I did is I talked to the counselor, whether it's at the high school or at the college that I'm at. You always want to look for those opportunities. If you can build relationships and find the local firms, you can always Google and look for mechanical engineers or mechanical consultants, for example, or civil consultants, and then contact them, do cold calls, and just send a letter to them and say, I'm interested in job shadowing or doing an intern where I could, support, an engineer or learn something and give you some work. Those are different opportunities you can do.
Perfect. And again, a message to the students, this is about those people skills and also communication skills. So being able to write an email that a professional will read, being able to follow up with those phone calls and introduce yourselves. Those are all skills that you can build right now to help with getting placement internships and someday in a job. So next question. Was there ever a time that technology has failed you? And what was the alternative method you used?
I want to tackle this one because it is still fresh and painful. We actually had a large computer downage about 2 weeks ago, and everybody's computers got to get wiped. And so what did we do instead? A lot of it is putting together what you can do. There's some things you can do hand counts on. There's some things where you can start drawing up the details of how things go together. And a lot of that, trying to fit pieces together, is things that you can do without having technology. The thing that doesn't get talked about very often at kind of like this level is that you are still a business with our professions. We love them for our own reasons, and a lot of the programs we have let you do calculations much more efficiently than you would be able to do them in hand calcs. But ultimately, you're responsible for what those programs tell you. And so garbage in, garbage out, you need to know if it's giving you garbage. And that's why you have all of those math classes, even if you don't use them, so that you can understand when a program's not necessarily giving you a design that makes sense. And so to do that, you go back to hand calculations, and your design will probably be more conservative because you're going to start making assumptions that you won't have to make if you have a program to do kind of the more in-depth analysis. But ultimately, everything you learn in college from your statics and your dynamics classes is going to be how you would solve by hand anything that you'd be doing if your programs were down and out. The programs just help you do more complex analyses, get more cost-effective solutions, which will ultimately save the client money.
Very good. It sounds like it wasn't a fun day though.
It wasn't a fun week.
I could answer that one as well, if I may.
Okay.
So as architects, we have to do presentations, and and we always have our nice presentations together on the computer, and we have animations, and we have, these beautiful pictures that we're going to present and project onto the screen. And, you're sitting there in front of a client, you're away from your office, and something goes wrong. Either their network's not working, or someone forgot to bring the thumb drive to do the presentation. And luckily, we make hard prints, so that kind of saved us. We do hard prints. I mean, it's not as flashy, it's not as cool, but that kind of saved us. Again, the printed media is always good. But one thing I wanted to mention, though, like one thing I think where technology has failed us is, one time we just said, well, let's just design a project and let's not do any sketching. Let's just see how it works out. Let's design it on the computer and let's see what happens. Let's work this out. Let's not be so old school and see what happens. And what ended up happening, it's what I kind of expected. It looks like it was designed on the computer. It looks like, and it feels like it was, there's a rigidity to it. It doesn't have that human touch, that it doesn't have that design that, I don't think a lot of us are there yet. Like some of the younger kids that come from, currently graduate, they do have more control, I think. They're with the mouth, they can use their cursors, they have different programs. They can get that kind of artistic touch that designs, call for. But as of like us, I mean, like right now, you could tell if we design something on the computer because it's real rigid. It's real boxy. It doesn't have any feel. It doesn't have any hierarchy and all those nice things you learn in design. So that's where I think design has at least failed me. It's getting better, but that's something we're still working towards.
Very good. Nick, any horror stories?
Oh, they happen all the time. It is what Edgar was talking about, the fact that we present to council. I've got backup upon backups because it's always something that's going to happen, whether our software, our network fails, or we don't have the thumb drive, or we have hard copies that we need to have ready to be handed out. And that's the last thing you want to do is when you're getting ready to present to council, which is technically our client, the public. If you don't have that information, you fall on your face, and you have to wait another 2 weeks before you can come back to the dais and explain it. Going back to what Megan said regarding the software. Anybody can learn how to populate a software and plug and chug. It's the answer coming out and looking at it, understanding the means, the methods, the regulations that all fall within it, and to make sure that math problem that you just plugged and chugged actually makes sense. So those are the life lessons that you learn hands-on doing the various things such as interns and climbing your ladder through the various employments.
Very good. Yeah, you have to have the knowledge behind the facts. So it looks like in our Q&A, we don't have any more questions. So I'd like to finish up this evening by each of you giving maybe just a couple words of advice. Megan, do you want to start it out for us?
Sure. For words of advice, I would say if you're at all interested in architecture or engineering, go for it. Most colleges will offer both. Funny story, I became an engineer because I was already going to UC San Diego and they didn't have architecture. I ended up switching into the major after the end of my freshman year. And I said, hey, I want to be an architect. Like, we don't have it. We have structural engineering. And I was like, okay, that works. Good enough. And been happy ever since. But I'd say go for it. The beginning classes you take are going to be very broad. And get out there, and getting an internship without a degree is going to be hard. But getting a job shadow and getting 15 minutes of somebody's time to kind of give you their take and experience on it is fairly easy. Everybody remembers when they're trying to figure out what they want to do. And so I'd say get out there, just start taking the classes, take the hardest of whatever is available, and you're slowly going to hone in on what it is that you want to do. You'll start realizing, hey, I like statics a lot more than I like dynamics. You're probably going to get more into structural or civil engineering. You like dynamics more, you're probably going to get more into mechanical or aerospace engineering. The coursework itself will help tell you what type of problems you like to solve, and that will help push you in the direction you want to go. But even then, you're never pigeonholed. I mean, going back to what I said earlier, engineering is problem solving. And switching between engineering majors or switching from an engineering major to a completely different major is entirely possible and extremely common, because a lot of other professions value the problem solving skills that engineers develop. And so it's probably more than a couple thoughts, but I'd say don't be scared of just making a decision and going for it.
That was great. Perfect. Thank you. Edgar, how about you?
Yeah, I mean, it's like right now, I mean, you want to get into architecture. A lot of my experience is you got to put the practice into it. Again, like anything else, you're going to get out of it how much you put in. And then with architecture, you kind of both sides of the brain, you know, like you got to do a lot of the writing, do a lot of journaling, and do a lot of sketching. My professor used to say, write, sketch. So that's, you know, that will kind of help you a lot. And again, learn how to work with people, learn how to do your own research, be self-sufficient, solve your own problems. Again, working on teams, that's very important. Learn how to do that now. And always, I mean, even to this day, I mean, it's always know that you're learning. Always learn. So that's my 2 cents.
Perfect. And Nick, we'll finish up with you.
I'm going to echo what both of my colleagues have stated. Don't ever be discouraged. You know, just because you're a freshman in high school or in middle school right now, and you just have that inkling towards engineering or architecture, but you don't know what exactly the field holds, you're at the best point in your life, because you can still make those decisions. In fact, you can make those decisions the next year or next 5 years, well into college. You can still make those decisions and shift and turn on a dime, but yet still stay in the engineering or architectural field and be successful. In fact, even after you go through all that, you can be similar to me, where I've turned and now I'm into the public sector, and I'm more of administration. And I have the expert knowledge in engineering, but I'm more into, you know, public administration, which you can go to college for that specifically.
I happen to know that oh, sorry, I didn't mean to cut you off. I happen to know that the president of COS actually has his degree in engineering. So yeah, there's a lot of areas you can go into. Good critical thinking and can take you a lot of places.
Yeah, our former 2 city managers here in the city of Visalia, Mike Almost, he was a planner, so it's a very similar to the engineering and architectural, and the gentleman before him, Steve Solomon, he's a civil engineer also. So there's a lot of different careers, and just mindset and process thinking will lead you down a different path.
Perfect. Well, I think our Q&A, I don't see any more questions. You've given us some great ending thoughts and a wealth of information tonight. And I really want to thank you for taking time out of your busy schedules, staying late at the office and spending it with us. And we hope to hear from you soon again. And again, thank you very much. And for our audience tonight, thank you for joining us. Next month will be medical careers, and we'll see you then. Thank you.
Thanks.
My pleasure. Thanks for inviting.
Bye-bye.
Bye.